This is a resting potential, minus 70. Here is the threshold, is around minus 60 millivolt. Okay, this is the action potential curved. Depolarization, when there's a rising of the curved, rising depolarization, repolarization associated with the falling phase of the curved. Okay, so when you give the stimulus very high, a high amount of stimulus will reach a threshold level, and then it will generate the action potential. This part here, when you give a very strong stimulus, the sodium channel or sodium voltage gated channel will open. Kat sini, it will open. That causes the sodium ions to diffuse into the cell and makes inside the cell more positive and causes depolarization until it reaches the spike. At this particular part here, okay, sodium potassium voltage gated channel starts to open. Potassium ions start to diffuse out of the cell, and then it continues to diffuse out. This is repolarization until inside the cell is more negative and it reaches this hyperpolarization or undershoot. And the membrane potential is around minus 80 millivolt. This is repolarization, the falling phase of the curved, and this part here is undershoot or hyperpolarization and is associated with inhibitory. We'll take a look at the stages. Resting, this is the resting. Depolarization, okay. Rising phase of the curved, associated with the opening of the sodium ions. Sodium ions diffuse into the cells and make it more positive inside the cell. Falling phase is the curve. Falling phase is associated with the opening of the potassium channel and potassium ions diffuse out. So inside the cell is more negative. Undershoot is this part here. We can call it as the hyperpolarization, and the value is around minus 80 millivolt. And we have the refractory period here. Refractory period. You can refer to Capital 12 edition, page 1133. So for refractory period, this is the time during which another stimulus, if you give another stimulus here, you will not generate the action potential. You cannot get the action potential at here around this refractory period. You have to make use of the sodium potassium pump so that you can get the resting membrane potential back, and you get all the potassium and sodium ions back to the original concentration as in the resting potential in order for you to generate another action potential. So